Hello, dear colleagues. Thank you for being here. My name is Ganna Kostenko. I'm a researcher from General Energy Institute of National Academy of Sciences of Ukraine. Today I will present the results of our research on preconditions and main features of electric vehicles application for frequency regulation in the power system. Power system needs to balance the processes of production and consumption of electricity in order to maintain a constant frequency in the grids. In cases where there is a gap between the generation and the load, grid frequency will change and its value will deviate from the nominal. Frequency and active power regulation plays a decisive role in providing consumers with electric energy of the appropriate quality. Effectiveness of regulation, first of all, depends on availability and type of system regulators. The possibility of providing frequency regulation with plug-in electric vehicles considered in this study. One of the main global trends of the last 10 years has been the gradual replacement of vehicles using internal combustion engines with electric vehicles in order to reduce carbon dioxide emissions. Over the past 10 years, significant progress has been observed in the adoption of electric vehicles in Ukraine. Even market development in Ukraine is presented here. Electric vehicles may be a solution for several power system challenges due to their capacity and quick response. Potential EV services for different power system levels are presented in this slide. With a well-developed market mechanism, electric vehicles as consumer regulators can be an effective source for operational and emergency reserves. This slide depicts the dynamics of battery capacity degradation. Usually, manufacturers provide an 8 years warranty, and as shown, the battery capacity and its regulation capacity decreases by 35% over 8 years of vehicle usage. Battery degradation reduces the driving range of the electric vehicle, increases charging times, and diminishes the overall battery performance. With the widespread adoption of electric vehicles, significant amount of electricity can be stored in their batteries. According to research, private electric vehicles are staying parked almost 90% of the day. It is practical to return accumulated electricity back to the grid and utilize it to balance the load curve through the vehicle-to-grid concept, which allows the bidirectional energy exchange between the vehicle and the grid. Vehicle-to-grid enables several tasks to be performed, such as frequency regulation, peak load reduction, consumer benefits, and energy reserves. This slide represents the vehicle-to-grid concept with an aggregator, which could be much more efficient. But aggregator should be able to participate in the electricity market, organizing and optimizing the charging of electric vehicles and managing the load profile. Aggregator plays the role of an interface between electric vehicle fleet and grid operator. Establish a connection, real-time connection to each vehicle, having information about the state of charge of its battery, and making a decision about participation in frequency regulation. This slide represents the significance of charging strategies and their impact on the daily load curve. The red line represents uncontrolled charging, also known as charging by demand. The blue line represents controlled unidirectional smart charging using tariffs. The green line represents bidirectional smart charging vehicle-to-grid, which returns electricity to the grid during periods of energy shortage to support peak power. The simulation was carried out for two work scenarios: the use as a frequency and power regulator of a hydropower plant with a capacity of 300 megawatts, or aggregator electric vehicles with the same total capacity of 300 megawatts. As it can be seen from the simulation results, electric vehicles exhibit remarkable ability compared to hydropower plants. Electric vehicles possess decisive advantages in terms of responsiveness. Electric vehicles are uniquely equipped to provide grid frequency and power regulation by dynamically participating in load shifting and energy storage. They can absorb excess power during periods of overgeneration by renewables and release it when demand surges, contributing to a well-balanced grid. In conclusion, electric mobility is a swift, adaptable, and forward-looking solution for Ukraine's transition towards a more dynamic and sustainable grids. For more detailed information about the subject, I suggest you to get acquainted with our papers. Thank you for your attention.